Okay, we are going to continue to analyze circuits, DC circuits that include series and parallel resistors. We'll go ahead and just do some numerical example. That's example one. Let's say that we have a resistor connected to other two parallel resistors and powered by voltage supply. The voltage Vs is equal to 22 volt. We have resistance R1 equal to 1 kilo ohm, and the resistance R2 is equal to 2.2 kilo ohm, and resistance 3 is equal to 3.3 kilo ohm. It's required to find the current through the resistors R2 and the current through R3. So we'll call the current I2 that flows in R2, and I3 is the current flowing in R3. We can say that the total current comes from the supply IT. So it's required to find the currents in this circuit. How can we solve this problem? To solve this problem, we have first to find the total resistance of the circuit. Why? Because the total resistance, if I can find the equivalent resistance of the circuit, I can find the total current. How can we find the total resistance? We look from the side and try to think about the connection of the resistor. Obviously, these two resistors are connected in parallel. How can we find the equivalent resistance of R2 and R3? That would be equal to R2 times R3 divided by the sum of the resistors. That's the rule for the parallel. So you have 2.2 times 3.3 and divided by the sum 0.2 plus 3.3. Doing that in the calculator, it will be equal to 1.32 kilo ohm. So now we can replace the circuit. The parallel resistor will be only equivalent to one resistance, and the value of this one is 1.32 kilo ohm. We complete the circuit. We still have another resistance, which is R1. It's equal to 1 kilo ohm. And the voltage supply, which is equal to 22 voltage. Now we have two resistors connected in series. That's 1 kilo ohm and 1.32 kilo ohm. So we can say that the total resistance RT is equal to 1 kilo ohm plus 1.32 kilo ohm. That will be equal to 2.32 kilo ohm. That will be the total resistance of the circuit. So it's easy now to find the total current flowing in the circuit IT. So the total current will be equal the voltage Vs divided by the total resistance RT. That's Vs, the supply. It's equal to 22 voltage divided by 2.32 kilo ohm. Since we are dividing the voltage by the kilo ohm, we expect that we get the current in milliamp. When you divide 22 by 2.32, you get on the calculator 9.48 milliamp. So that will be the total current. But it was required to find the current I2 and I3. Why I found IT? Because without IT, we cannot find I2 and I3. So IT now, it's the same current flowing in the resistance R1, and we calculate is equal to 9.48 milliamp. When you look at this current entering this junction, it will split into two currents, I3 and I2. So we can use current divided rule. So let me just sketch the circuit back here again, the original circuit in an easy way that we can, so we can find the solution of the circuit. Well, that's the current we just calculate, the total current, 9.48 milliamp, and it will split into two currents in the two resistors, and just put the value of the resistance, 2.2 kilo ohm and 3.3 kilo ohm. And we said that this is equal to I3 and this is equal to I2. So how can you find the current I2 or I3 using the current divide rule? Well, let's just find I2. If you want to find I2, you will say it's equal the total current entering this node, and then you multiply by the opposite resistor. What does it mean, opposite resistor? This is R2 and this is R3. If you want to find the current I2, you multiply it by R3 divided by the sum of both resistors, R2 and R3. The total current in this problem is equal 9.48 milliamp. R3, the opposite resistor to I2, it's equal to 3.3 kilo ohm divided by the sum 2.2 plus 3.3 kilo ohm. In this way, we can find the current I2, which is equal to 5.69 milliamp. So that will be the value of I2. How can we find I3? Well, using Kirchhoff current law. At this node, you have the current IT, which is equal 9.48, will split to I2 and I3. So you have one current inputting this node and two currents coming out of the node. So according to Kirchhoff current law, we say that the sum of the input current equal the sum of the output current. So 9.48 milliamp will be equal to the sum of I2 plus I3. And already we got I2. I2 is equal to what? 5.69. 5.69 milliamp. That's I2 plus I3. So I3 is equal the difference between both current. So I3 is equal to equal to 9.48 milliamp minus 5.69 milliamp. You get the value of I3, which is equal to 3.79 milliamp. Doing that, we found the value of all the currents in the circuit. Okay, let's have a more example. Our example 2. We have circuit here. And there's a resistor. That's Vs, node A, node B, and that's a resistance R2, which is equal to 330 ohm, R4 equal to 560 ohm, R3 330 ohm, R1 560 ohm, and the current in R1 is equal to I1, the current in R2 is equal I2, and the current in R4 I4, the current in R3 is equal I3. Okay, so that's the given. Well, what's required? it's required that if the voltage is equal to 50 volt, that's the volt of the supply, what is the value of I4? So it's required to find I4. Okay. Let's just think about the strategy of the solution. How can we find the current I4? You can find the current I4 if you know the current I2, because I2 entering node B. So if you know the current I2 that coming to B, you can use current divided rule to find I4 by using the ratio of the resistance. But the problem that we don't know I2. To get I2, you have to know the I total. And then, so you got to simplify the circuit. You got to find the equivalent resistance of this circuit. So let's just go step by step, because it's a big circuit a little bit. So you go on the side and just look, you find that two resistors are connected in parallel. How you find the equivalent resistance of R2, R3 and R4? You multiply the two values, 330 times 560, and you divide it by the sum, 330 plus 560, to find the value of the parallel resistor. Okay, let me just calculate this value. That would be equal to 8, 0, 2, 1. Now we can sketch the circuit after we found this parallel. So you will have one in the top, which is equal to 330, and you have now this resistance. You just calculated the equivalent of the parallel, which is equal to 108 ohm, and you complete the circuit. So you'll have, already we know that this voltage supply equal to 50 volt, and you have in the middle one resistance equal to 560. You still have the current here called I1, and here is called I total, and that's I2. It's still I2, everything here. All right. Now we have the resistance 330. It's connected in series with 280. So I will just add them because they are in series. So you have 330 plus 208. You got 8, 3, 5 ohm. That's the value of the resistance. So now we can re-sketch the circuit. You have one resistance, which is equal to 538 ohm, and you have the power supply has voltage equal to 50 volt, and you have resistance R1 that's equal to 560. And remember, that's I1, and that's I total, and that's I2, still I2 coming out from here. Now we have two resistors are connected in parallel, but I don't have to get the equivalent. Why? Because this voltage, because you have to remember that you need to find, just focus on the problem. You need to find I4, and to get I4, you got to know I2. So it's important to get I2, and that's I2 here. In this branch, this is all I2. And you already know the voltage across 538 ohm. You know the voltage across, it's equal 50 volt. Because you don't have any resistance here between this node and this voltage supply, so it means there is no voltage drop. So the 50 volt is up, it's across 560 ohm, and also it's across 530 ohm, 530 ohm, 8 ohm. So now I can find I2, and just let us make it clear, because the voltage across here it's equal 50 volt, and also across here it's equal 50 volt. I don't need to find I1. I need I2. So now I will say I2 is equal the voltage, which is equal to 50 voltage divided by the resistance 530 ohm. It will give the current in I2, which is equal to 93 milliamp. So I got I2. The problem is almost solved. I go back to the problem here. That's I2. That's I2. So I2 entering this combination of R3 and R4. I will just take a copy of this part, have it here, Oops, I'm sorry, that's wrong. Let me just okay. Copy. Okay, here you go. So I got the part that I'm interested in. When you look at this circuit, you'll find that I2 is flowing here in this branch, and it come at node B, it will split into two. R4 and R3 are connected in parallel, so I can use the current divider rule. What the current divider will say, I want to find I4, you have I4. So we ask, what is the current entering this node B? It's I2. What is the value of I2? We just got it. It's equal to 93 milliamp. So I will multiply 93 milliamp by what? I want to find I4. So you look for the opposite resistance R3, which is equal to 330 ohm divided by the sum of the two resistors, 330 plus 560 ohm. You get the current I4, which is equal to 34.5 milliamp. That would be the answer for the problem. So that was another good example. Let's take more example here. Okay. We have a voltage source. And this voltage source, the S, that's the positive and the negative, and the current I total is given to be equal to 1 milliamp. And we have two resistors connected in parallel. One is equal to 2.2 kilo ohm and the other is equal to 1 kilo ohm. Then we have another two resistors connected in parallel. The value of this resistor 3.9 kilo ohm, and this one is equal to 561.5. I'm sorry, I didn't write it right. And this one is equal to, actually there are two resistors, 1.5 kilo ohm and another one 560 ohm. That's the circuit. The all resistors have values. The all resistors have their values, and I have the total current value. I don't have the value of the voltage supply, and it's required to find the voltage drop across each resistor. So how can we do that? Well, first we have to find the equivalent resistance for the whole circuit. So we can do that by finding the value of this resistance and this resistance, find the parallel of this one and this one. But you ask yourself, why if you do all that, if the current is given here, can you find the current here and the current here? Yes, you can. So go ahead and use the current divider rule just quickly. So that what is the current here? Let's just call this one I1 and this I2. So what is the value of I1? I1 would be equal to the total current, which is equal to 1 milliamp, multiplied by the opposite resistance 2.2, divided by the sum of the resistance 2.2 plus 1 kilo ohm. So you get 2.2 divided by 3.2. All right. So let's just do that in the calculator. Let me calculate it. It's equal to divided by, that's equal to 0.6875. All right. that will be milliamp, because you're multiplying here 1 milliamp by this, and so that will be equal the value of each current. If you want to find the voltage across these resistors, so actually the voltage across 1 kilo ohm is the same as the voltage across 2.2 kilo ohm, because these two resistors are connected in parallel. So it's just enough to find the voltage drop across any one of them. I will choose the easy one, 1 kilo ohm. What is the current in 1 kilo ohm? Just let me sketch it here. You have 1 kilo ohm and you have the current I1, which is equal to 0.6875 milliamp. I multiply, so the voltage across 1 kilo ohm, it's equal to 1 kilo ohm times the current, which is equal to 0.6875 milliamp. And since you multiply the kilo ohm by milliamp, you get the voltage. And 1 time this, we get 0.68, and let's just round the number. So that will be the voltage across this resistor. Then you ask, okay, what about the voltage across 2.2 kilo ohm? Don't waste your time, because the 2.2 kilo ohm is connected in parallel to 1 kilo ohm. So the voltage across 2.2 kilo ohm is the same voltage across 1 kilo ohm. So we are done with this part. Now we go for the other one. Remember that when the current IT 1 milliamp, this current 1 milliamp, when you go to split I1 and I2 and then come back again this node, they will add back again. So the current coming out here will be I1 plus I2, because this is I1, this is I2. So go back as it was entering. So you will have 1 milliamp here again. That's important to know, not to waste your time. The current come to this node, split, and then comes back again, and then add to again. So it becomes the same value, 1 milliamp. So 1 milliamp going there, all right? So you want to find the voltage drop across each resistor. They are connected in parallel. Again, what you're going to do, we are going to use the current divide rule. Call this I3 and that's called I4. Remember that 1.5 kilo ohm is connected in series to 560 ohm. And pay attention that that's in kilo ohm and that's in ohm. So you have to convert the 560 ohm to kilo ohm. How you do that? You divide this by 1000. So it's equal to 0.56 kilo ohm. And then you are going to add it to 1.5 kilo ohm. If you add this value, so you get 1, let me just do it here, 1.5 add to 0.56. Put 0 here, so when you add 0 and 6 is equal 6, 5 and 5, 0 and have 1, 1 and 1, 2. So it will be 206 kilo ohm. Okay, that's important to have the same unit. So what you're going to do now, I will just sketch here the two resistor I added. And remember that 1 milliamp entering this node, and the value of this resistance 2.06 kilo ohm, and the other one 3.9 kilo ohm. We call this I3. So I'll just enough to find I3. If you want to find I3 will be equal to the total current, which is equal to 1 milli ohm, multiplied by the opposite resistor, which is equal to 2.06 kilo ohm, divided by the sum, 2.06 plus 3.9 kilo ohm. Let me do that on the calculator. 2.06 divided by 2.06 plus 3.9. So that would be equal to 0.3456 milliamp. I want to find the voltage, and the voltage across any resistance. Choose any one. I will choose this one. So the voltage across R3, it's equal to 3.9 kilo ohm multiplied by the current. The current already calculated here is equal to 0.3456 milliamp. Since I'm multiplying milliamp by kilo ohm, I get the answer in volt. I will just do that on the calculator here. 3.9. That's equal to 1.348. Great. So, let's have more problems. I'd like to show you something. It's useful, and that when you have like voltage source and how we convert voltage source to current source and vice versa. For example, let's say that you have voltage source, and this voltage source is connected to resistance, and you wish to convert this to current source. For example, let's say that's equal to 50 volt, and that's equal to 10 ohm. To convert this to current source, you convert it to current source in parallel with resistance. That's how you do that. So voltage source connected in series with a resistor can be converted to current source in parallel with the resistor. The resistance is the same value, it's 10 ohm, as we have in this example. What about the value of the current source? You divide the value of the voltage by the resistance, you get 5 amp. So 50 voltage connected in series with 10 ohm can be converted into current source equal to 5 amp connected in parallel to 10 ohm. That sometimes help in solving problems. All right. So let's just take one example. Somebody asked, okay, what about if you have current source connected to in parallel to a resistor? Can you convert it to a voltage source connected in series with a resistor? Yes, you can. You can do it in the other direction too. That's true. So let's take one example. If you have a voltage source, and this voltage source is equal to 100 voltage, and there is a resistance here is equal to 10 ohm. That's the resistance of the source. And then you have load here, and this load is connected to some resistance RL, whatever. So how you convert this one to current source? Very simple. You just look for the voltage source, and it's connected with resistance in series. So you can do it as voltage source. How the value of the voltage source here, direct upward. And then you ask why direct upward? Because this is a positive upward, so the arrow of the current will be also upward. What is the value of the current? You divided the value of the voltage supply, 100 voltage, by the resistance, which is equal to 10 ohm. That's equal to 10 amp. So this current source is equal to 10 amp, and you connect it in parallel with the resistance, which was connected in series with the voltage source, which is equal to 10 ohm. You are done with the conversion. Now we can continue and complete the circuit. We have load here, RL. Then you can add the resistance of the load as it is in the diagram. Okay, great. Well, what about now if we say that, let's assume that the value of the RL is equal to, let's take any value here. Let's take it equal to 100 ohm. To solve, let's say that you want to find the output voltage here. I will solve this problem using the two diagrams here. Let me use first when it's connected before I do any conversion. How can you find the voltage here? I will use voltage divider rule. How you use voltage divider rule? I say the V output is equal to the total voltage, which is equal 100 volt. And then I will say I want to find the voltage across the resistance RL 100, so that will be in the top. Divided by what? The sum of the resistance in the circuit, 100 ohm plus 10 ohm. That will be equal 100 times 100 over 110. It will give you the value on voltage, which is equal to 90.9 volt. I used voltage divider rule, not current divider rule. Why? Because they are connected in series, the resistance. Here, to find the voltage output across this resistance, I should find the current. Why I should find the current? Because you have current source, and this current source is equal to 10 amp. So it's like 10 amp branching, and then we'll come to this node, it will be divided into two currents, current in this resistor and current here, which is the current through the load. I'm interested in this one. So what I'm going to do, I'm going to use current divider rule. How you use this, you say IL is equal to the total current, which is equal to 10 amp entering the node, time the opposite resistance. That's the difference between current divider rule and the voltage divider rule. What is the opposite resistor to the IL? It's 10 ohm. So multiplied by 10 ohm and divided by the sum 10 ohm, and the RL is equal 100 ohm, as we said in the example, it's equal 100 ohm. So you will have 10 times 10 over 110. You get the current flowing through the load, which is equal to 990 milliamp. That's the current. But it was required to find the voltage. Okay, it's easy. If you want to find the voltage across RL, all what you're supposed to do, you multiply RL by the current IL. RL is equal 100 ohm, and the current is equal 99 milliamp. All right, if you divide this by 1000 to make it amp, so you'll get 90 point, no, I think it will take it like 90.9 or 99.9. Okay, be close to the other because we round the answer. So that's you got 0, 0, and 100 with 100. So you got 99 voltage. Okay. Okay. What else? Let's take one more example. Okay. Let's say that you have a current source, and this current source is equal 10 milliamp, and you have a resistance, and this resistance is equal to 1 kilo ohm. All right, and it's connected to other resistors in the circuit. Let's say 2 kilo ohm, 3 kilo ohm, and let's say that we want to find the voltage across 3 kilo ohm. To find the voltage across 3 kilo ohm, it's easy. You can use current divider rule. You have 10 milliamp entering this node, so the current will be divided. I am interested in this current I1 because I want to find the voltage across 3 kilo ohm. So you will say I1 is equal to the total current, which is equal to 10 milliamp, multiplied by the opposite resistance, which is equal to 1 kilo ohm, and divided by the sum of the resistance of 1 kilo ohm and the other branches too. You have 1 kilo ohm plus 2 plus 3. That will be equal 10 milliamp, and multiplied by 1 and divided by 6. So we have 10 over 6 voltage, or you can say it's equal to 5 over 3 voltage. All right. Now, I'm sorry, that's current. I didn't multiply. That's current. I'm very sorry. That's milliamp. Now I found the current here flowing in 3 kilo ohm, 5 over 3 milliamp. Of course, you can convert to decimal, but just I will leave it like that. 5 over 3 milliamp. I want to find the voltage across 3 kilo ohm. So how to find the voltage? You multiply the resistance by the current. So you have 5 over 3 milliamp multiplied by 3 kilo ohm. That 3 cancel 3, so you will have 5 voltage. So the voltage should be equal 5 voltage. That's one way to solve the problem. Okay. Another way to do it, you can convert the current source into voltage source. They are connected in parallel. So what you'll do, you multiply the value of the resistance by the value of the current. 10 milliamp times 1. So you will have the equivalent voltage will be equal to 10 milliamp times 1 kilo ohm. You will get 10 voltage. So you convert it to voltage equal to 10 voltage. The positive is up and connected in series with the resistance. What's the value of the resistance? 1 kilo ohm. I am using the same value of the source resistor. And then I complete the circuit. I have 2 kilo ohm and 3 kilo ohm. So I have 2 kilo ohm and 3 kilo ohm. All right. So when if you can sketch it again like this 3 kilo ohm, that's where you want to find the voltage across. And you have 2 kilo ohm and 1 kilo ohm, you can add them together, you'll be 3 kilo ohm. And the voltage is equal to 10 volts. So when you look at this problem, it's really easy. Why? Because you have 3 kilo ohm, another 3 kilo ohm, 10 voltage. So this voltage is going to be divided equally because they are equal resistance. So this will be equal to 5 voltage. Even using the voltage divider rule, you will say the output voltage is equal the total voltage, which is equal to 10 voltage, multiplied by the resistance, 3 kilo ohm, divided by the sum of both resistance 3 plus 3, which is equal 10 times 1/2, which is equal 5 volts. The same result. I hope it was useful, and thank you for your attention.